In this video, we're going to introduce the concept of a series and how it is related to a sequence. Okay, so we say many applications when we talk about sequences, they involve the sum of the terms of some finite or infinite sequence. Okay, so basically we have some sequence of numbers, essentially, that we want to add up a certain number of the terms together. Okay, so we call these sums, we call these series. Okay, so to be very clear on this, we say a sequence. If I had to define a sequence, it is any list of ordered elements. Okay, so we typically discuss numbers, I would say here. Any list of ordered elements such that, there's a first element and a second element and so on. So such that there exists, a first element, second element, and I'm going to say etc. ad infinitum, basically. And basically that just means, so on forever and ever. A series, however, essentially is this. It is a sum of some, S-O-M-E, or all of the terms of a sequence. Okay, so just to be very clear on this one, a series is what you get when you add together a certain number of terms of some sequence. So we're going to define a series thusly, and then we're going to go ahead and find some sums here. But it says consider the infinite sequence A1, A2, A3, AI, all the way on, so forever and ever. We could have some AN, and it extends further past this even. But essentially, we have some sequence of things in order, and these are its terms. We say the sum of the first n terms of a sequence is called a finite series, or nth partial sum of the sequence, and is denoted by this. Okay, oh my goodness, this is a lot of information. So basically, let's start with this. If you add up basically the first n terms, so let's say n is 10, say go find a10, or the sum of the first 10 terms. We would say that it's a finite series because it is a series. It is a sum of the terms of a sequence, but only a certain amount of them. Okay, so like the first 10 of them. So we're also going to call that, if I wanted to find, A1 plus A2 plus A3 plus, and I'll write this out here, plus, A10, we would call this a finite series. Okay, so a finite series, and we would call this the 10th partial sum. Now, when you talk about partial, something is partial. It's like a part of something or a piece of something. So we're only adding together the first, say, 10 terms of this. So that's why we call it a partial sum. It's not the sum of all the terms. Now you notice I said this. It's denoted by A1 plus A2 plus A3 through AN. In this case, I'm using n as 10 here. But we'd say I could also have written this as the sum of this, where remember that this is the rule here for our sequence. And then we say we're adding these terms, the first term out to the nth term. And in this case here, I would say that this would be the sum of, we would say I, starting at 1 and going out to 10 for some rule AI. Okay. So now if we were to change this, we say the sum of all of the terms of the sequence, that would be called of an infinite sequence. We would call that an infinite series. Okay, and it's denoted by A1 plus A2 plus A3 plus AI plus, and go on forever and ever. You might think to yourself, how could you add together infinitely many terms? But this is a possibility, and we have to acknowledge that it exists. And we'd say starting at the first term going out to eternity. So you'll notice I use the infinity sign as our upper limit on summation this time. Okay. So what we're going to do this time, we're actually going to look at an infinite series here, which is an interesting thing. But it says find the sum of the series. We're going to do some partial sums first, and then we'll talk about the sum of the series. Okay. So it says, first of all, find the third partial sum. Now, what I want to do is I want to start by saying a few things here. Up here, when we had written the sum, the series here, I wrote it in summation notation. But we could actually write this as a capital S as well. So when you see this here, I could have called this S10. This stands for the sum of this many terms, of the first n terms, where n in this case is 10. So we could say find the third partial sum, we say is S3. We could also list it this way. We're saying starting at the first term, and going out to the third term of our rule. And our rule in this case, you notice that we've been given the rule. And the rule this time is 3 over 10 to the I. So we say 3 over 10 to the I power. So what this means is we're going to take this and we're going to add together a1 plus a2 plus a3 essentially. And so we'd say a1 would be 3 over 10 to the first, so we get 3 tenths, plus now 3 over 10 to the second for a2. So we say 3 over 10 to the second is 3 hundredths. And we say 3 over a to the third, or 3 over 10 to the third, which is 3 over 10 to the third is 1,000. So we get 3 thousandths. Basically here, if we were to put this into a calculator, you could check this, you get 0.3 plus 3 hundredths, which is 0.03 plus 0.003 is 3 thousandths. You get this, you get 0.0333. So you get some finite sum here, okay? And if we were to do the fifth partial sum, I wanted to see a pattern here, but we'd say the sum of the first 5 terms. Now we'd write capital S with a lower subscript 5. This is the same thing as the partial sum, the fifth partial sum of the series, okay? It's fifth partial sum. So we want to do our same rule here. We'd say 3 over 10 to the i-th power. And so we'd get now 3 tenths, but also plus 3 hundredths, plus 3 thousandths. And you could see how this is going to kick into, I'm going to write down here, 3 ten thousandths plus 3 100 thousandths when we plug these things in. So in this case we get, on a calculator, 0.33333. And so if we were to do the sum, now the interesting thing here is, notice on this last one, it's not a typo, it says find the actual sum. So we're going to use just a capital S, and we say, well, what sum? All of these. I want to add together all of the terms, infinitely many. And what you can see is, if this pattern were to continue, what we do is we approach this infinite sum, which I wanted to note is a third, basically. We would get a third exactly. So don't be fooled into thinking if you add together infinitely many terms of a sequence that you get a series that has an infinite sum. You actually can get a finite sum, a number that can be counted from a sum that added together infinitely many terms. Cheers.